really appreciate the invite to come and present to everyone this morning. And we're going to run through, I guess, a bit of a history of Candour and where we came from and some of our projects, and really sort of outline what our company's about and what problem we're trying to solve. Because we are taking a slightly different path, I think, than some others within the industry, and partly that's because from our experience as architects working through Archer and other practices, we feel that often the real problem is not really being engaged with, and we'll step through how we've come to this as a kind of focus for our business, and also really focusing on producing an architectural prefabrication product, really hoping and looking to reconceptualize what prefab can be. I think it's often seen as a lower cost, lower quality outcome, whereas we're really looking to how we can use it in an architectural way and deliver some of those benefits of offsite manufacture around quality, efficiency, and cost control to that architectural end of the market. And as we grow, being able to offer that to an expanding pool, sort of mid and even lower cost in the long run, is where the goal is. So, as Kylan noted, we evolved out of Archer, which has been running sort of about 10, 15 years. And Candour was founded by 5 co-founders, so myself and the 4 directors of Archer, and now 3 of us. So Josh, who is our technical lead, who's on the Zoom with us today, and John, who runs our factory, and myself are the sort of full-time within Candour, and Josh also leads Archer as well. And then the other guys are off doing other things. So we've got Chris Gilbert, who's working for Ash, so a very close collaboration with Candour and Archer as well. And then Chris Haddad, who's remained in Archer too. So interesting, a lot of where Candour comes from is really through the lessons that we learnt through Archer and architectural practice, starting way back with Sawmill House, which was built quite conventionally. And even the guys from Archer were there on site with Ben, who's the brother of Chris Gilbert, building it with him. And that first-hand experience really exposed the challenges and issues with conventional building. And primarily that lesson was around coordinating different trades and the delay that often happens between those different stages, is have to getting one element done to be able to measure to do the next. And then also the tolerance difference between those systems and how you kind of need to fill those gaps or reduce those to produce a high performance building. So with Archer's focus on trying to produce those really sustainable, efficient, low cost buildings, they then moved to looking at, well, okay, what's some of the solutions that are in the market at that time? And this was sort of 10, 15 years ago. And we're one of the early adopters of using SIPS panels. So this is down in Tassie and Hobart, one of the early homes in Australia to use SIPS, which is the structurally insulated panel, which you can see there on site. But shifting to a prefab system like this, interestingly, because it's so different to the way typical builders work, and even the way design happens in Australia, it caused a lot of challenges in the sort of design and procurement process, in the sense of the builders would put extra risk margin for an unknown system. They needed a lot of hand-holding around how to actually deliver it, to the point where actually we went to site to actually help them and assist them and guide them. And because it's a system that's very hard to alter on site in terms of a lot of the penetrations and those kind of things are done in the factory, and you need different tooling and those kind of things, it puts a lot more load and requirement on the designers to get it right. And so these were all lessons that we were kind of picking up over the years around, well, if we were to develop an approach to this, a solution in this market, what would we learn, or what would we do differently? How could we make it really broadly appealing and applicable to both builders and designers? And also, lowering the load on designers as well. So these sort of lessons, while slightly different, apply whether you're using a small scale prefab company like the SIPS ones, or through to some of the largest in Australia. So this building is the Parks Victoria headquarters in Albert Park that was finished a couple of years ago. And this uses some CLT produced from Austria, from KLH. And interestingly, this had its own sort of issues in the project where it was engineered and certified in Australia. Then the KLH rep looked at it and was like, well, that's not how you do it, and changed the details. The factory over in Austria then looked and was like, well, that's not how you do it, and changed the details without really informing the project team. Right back in Australia, the builders assembled it, they worked it out, but then it failed its framing inspection because of it wasn't to the documentation. And that really illustrates that separation that exists between the manufacturer often and those that are actually designing and even making the building. And you're not really talking to them until way too late, or there's no clear integrated process to integrate their details and information. And this seemed to be sort of repeating lessons and repeating issues. And this really came to a head in one of the final projects that we were working on in Archer, which was the corner house. Again, a really successful building, really high performance, great quality, award-winning building. But the process to procure it and design it was very challenging. And again, you're trying to bring together SIPS panels, structural steel, floor-to-ceiling glass, and a really great builder. And it still had a lot of these challenges in terms of how you'd actually integrate the lessons. And again, because you're not talking to those manufacturing until much later, a lot of the benefit that could have come from those at the design phase was missed because you just don't have the chance to actually update it or include that. So this whole sort of experience really illustrated to us that the problem that needs solving is not actually prefabrication or offsite manufacture. It's the information vacuum that exists between architects and their clients and those designing the building, and then those actually manufacturing or constructing it. And that we need to shift that relationship and bring that connection, that information much earlier in the process, allowing people to actually make decisions with information, with agency. We often found that things like sustainability information or engineering benefits, it comes much too late to then actually integrate those and change the design. It really needs to be at that conceptual design phase. So after many years of thinking and testing and working, we refined Candour to be two core things. And it's quite conceptually simple, but quite complex to deliver in many ways. So what Candour is we're a software company that develops custom software that integrates with BIM packages that allows designers to create custom designs with our prefab platform. And that means that you can create, unique designs that suit your brief and budget and site and scale. That then uses standardized connections, allowing you to get things like instant pricing, embodied carbon calculation, access detailing that's in the tools itself, with a real focus on how we can really improve that procurement process, that the design process, and allowing you to connect with the fabricators, manufacturers digitally, not necessarily through having to have a personal relationship or having a conversation or those kind of things. So we were really looking at, well, how can we actually reduce the load on designers, allow them to be faster and more efficient, and reduce that sort of learning curve to actually produce high performance, better quality buildings as well. So a lot of this stuff, if you just sort of apply our platform in a standard way, it delivers that kind of quality. And because it's connecting to our fabrication facilities, you're actually, that design for manufacture information is already embedded in there. So this is a little demonstration video that I put together almost a year ago. So with our software, so the software has evolved a little bit since here, but it gives you a good indication of that kind of user experience that you would get from it. So basically, we've created BIM objects or families in Revit for our building components. And you can see here that it allows us to embed features like when it turned red there. So around manufacturing constraints or engineering constraints. So say that was the span was too far for those joists. And so it's saying you need to reduce those or change those. And in the future, it'll be able to automatically update those based on the spans. But it can also embed other features, say like a pop-up that says, okay, you've made that piece of glass really large, above 6 square meters. That's now an 8 mil piece of glass. It's quite expensive. Is that actually what you intended, or are you happy to go for a tighter mullion spacing and therefore a cheaper cost? So a lot of the stuff that you just wouldn't know as a designer unless you have that close relationship with the manufacturer, we can add all those features and benefits into the tools itself. And then, like we're providing a quick instant pricing calculation here, you can also get an instant carbon calculation. And that comes right at the front of your design and conceptual design process. So your clients can also have the agency to say, okay, well, I can see if I make this choice around what the composition of the panels is, it has this added carbon, but it increases the price. Because often that stuff comes once the design is locked in, or even once the planning and other permitting and approvals are done, that you're basically not able to really change it or make those decisions around what you might actually value or prioritize. So you can see here as you're stepping through, and again, that changes red because the spans are too long here, but we're basically mocking up a small cabin building and illustrating how you can price check as you go with our components and our panelized elements. And you can also add in all the different types of structural elements. So walls, we've got floors, we've got the glazed structural facade system that we do in there as well. And you can see here now that I'm adding in some other suppliers' components. So this is actually the BINC operable doors and windows. And this is a sort of larger scale idea for this software platform, is that we actually want to have other suppliers' systems on board. So you as a designer can actually pick and choose between other modern methods of construction companies. So it might be CLT or other like prefabricated systems, where you can actually say, okay, I want to try this wall system with this floor system with the Candour facade, and actually get the best outcome for your project and your client and your site, not just having to be locked into one supplier or one system. We're also really excited about the kind of granularity that this can give you from a design perspective. You can really drill down really quickly and say, okay, well, how much are my roof structure costing me, or those deck cassettes that I've just modeled in, and what happens if I change the composition of these things or what they're built up from. And that user experience being that you can either select it in the ArchiCAD interface like we're doing now, just highlighting these components and shift selecting to say, okay, well, what's all the decks cost? Or you can do it in the pricing software that's there on the left, that's actually popping up natively within ArchiCAD as well. So you'll get the experience to be able to sort of export all of this information, but you can also log into a browser and it tracks all your different projects, all the different pricings you've done, as well as connecting it within the software itself. So for us, this is really around how can we improve that process for people to get to a project that's on brief, on budget, that aligns with the client's desires and outcome, and allow you to move forward more quickly, and then also be able to take advantage of all these different suppliers, systems, and components more readily. So we're currently using this within Candour. It's still a sort of a work in progress. To be honest, it's a pretty challenging process what we've bitten off, in the sense of developing a software company and a manufacturing business, almost two different businesses in one, coming from architecture background. So that's not our area of expertise as well. So we're really bootstrapping our business too, in the sense that we're self-funding it through the profits and the revenue we generate. So we're really jumping from one to the other often, but we are making some really exciting progress with the software. It's just taking longer than we would have anticipated there. But one of the things that we're really focused on with our approach is looking at that entire timeline of a project, not just as we find a lot of other prefab providers will do, is they'll sort of promise really big savings or time savings or cost savings in construction. But if we're looking at the procurement and design process as well, then that's actually, as that blue section is showing on this slide, the much bigger area where you can have impact. And we found through some case studies that we'll step you through in a second, that if you really lean into our system and our process, that you can actually really compress and condense that blue section, almost halve it or even less than that. We've got one project where we did it in a quarter of the time. And just that time saving alone is a massive cost saving if you're just talking about inflation. And then, yes, you can also find some on-site savings, especially around getting the building to lock up if you're leaning into the efficiencies of our system. So the way that our platform actually works is we're a panelized prefab platform. And we've done this for a couple of reasons in contrast to modular, because it's much more flexible. So we can use it on a wider variety of project types and sites. So we're not as constrained by access or site complexity. And say in a really challenging site, you can even provide the sticks, which are then assembled on site. So it's prefabricated, pre-finished, hardware's installed, but then the sticks are assembled on site. Right up through, you have large assembled panels with glazing installed that's craned into position. We also found that modular design can be much more constraining in terms of how designed, like the design of the outcomes, because it's often designed to fit on a truck, and the geometry and form of the buildings is often really impacted by that. And then you're also having to include a lot of structure that's redundant. It's there for lifting and moving the things rather than just being what's needed in the building. And we're really focused on that material efficiency and that embodied carbon around what we can build. And on that note, we've really lent into, so we're a completely timber-focused system or prefabricated platform. And some of our elements you notice on this slide here, which is really the core of what we do, and we're expanding that range as well. Some of them are more ubiquitous or common. So you've got, say on the right there, a wall panel, which is basically like a timber-framed wall with an OSB sheet, to ones that are much more unique, say one on the left, which is our structural facade system, which is a engineered timber or glulam timber frame, which we source locally and manufacture in-house. And then we import a European glazing adapter system that's completely thermally broken that face fixes the glass onto the outside of the wall of that frame. And this element in particular is quite a unique one because it allows us to do what's considered to be a sort of expensive architectural element, like these long floor-to-ceiling glass walls, for a fairly cost-effective price, because it's doing multiple roles. It's not only the window or the fixed glazing, but it's also the structural system. So the mullions are actually the columns. And it actually can become a construction logic for the project as well, where you're lifting these big frames into the building. You can have solid panels infilled into them. You can have operable doors and windows, fixed glazing. And once you get that glass on, that's your wall done. Inside finishes, outside finishes. So it can really compress that construction time, because even say a normal stud wall, you've got to clad it externally, you've got to insulate it, you've got to line it, you've got to paint it. All of these steps just really have many trades and really stretch out that timeline. Then in the middle, we've got things like our floor cassette structures, which you can see there has got a concrete screed. So that's an option we can offer for those projects that want to have, say, hydronic heating and cooling, or that need for extra thermal mass. But the key thing is it's still all timber based. And so the timber cassette is installed on site onto stumps or something like that. And then you can pour that concrete screed on site. And the next one then is our exposed rafter roof cassette. So there's many options around how you can vary the buildup of these. So there's more cost-effective versions, say, that might use LVL and then are sheeted internally. But these are illustrating some like what's common for us and what people often come to. You'll also note by this being componentized, we can integrate this with conventional systems too. So you can still just use our facade and our roof, which happens on quite a few projects, and then combine with conventional buildings like frames that are assembled on site and built on site, or a slab that's on ground. And you'll see an example of a project like that. But you really start to get a lot of the benefits of prefabrication when you really lean into the full platform. So this is an example of that, where you're doing everything basically from the stumps up. So floor cassettes, walls, facade, and roof system. And everything that we make is designed to be up to passive house, if that's what the project wants. But there's options to lower that specification, that performance as well, and obviously the costs from that. So we've set up our own factory out in Tottenham, sort of near Sunshine in Melbourne. So it's about half an hour from the CBD. And one of the things that we've done a little bit differently, I think, to a few other smaller scale operators in particular, is that we've really lent into automation from the start when we've set up our business. And one of the big things we made, especially around timber fabrication, was we procured a Hundinger robot saw. It took about 2 years to get it, just in terms of the lead times of it. And obviously it's a massive investment for a small scale operator. But one of the reasons we did this is because it really allows us to bring back craft and that really kind of intricate, highly accurate sort of timber joinery that often is just too expensive, or even our trades don't have this kind of skill and experience to deliver anymore. You can see from this video the kind of intricate detailing that these sort of machines can just do so quickly. And the other challenge we often found previously trying to do this work is that a lot of the manufacturers are not set up to work easily with designers and their clients to actually detail this and help them understand what's possible. So through our digital tools, we could actually just as a standard integrate this kind of thing. And you know that if you're building with us, you're getting the kind of refinement of detailing that comes from these sort of tools and equipment and processes. The second important reason we wanted to go down this path is that it actually allows us to embed the assembly logic of each part into the part itself. So you can even see with these how everything, all the connections are machined in, all the drillings are machined in. And it means that when you get that on our, say, assembly tables, even for the most basic floor cassette system, like it's shown here, an LVL floor cassette, it's mortise and tenon, it's pre-drilled, so you can notch them together, screw them off, and it's accurate and really fast to assemble. And it means that we can also have a much more diverse and smaller workforce as well, because we're really putting that labor or machining that labor into the parts themselves. So we can be a bit more nimble with how we grow our business. So these kind of things and the integration of the software, the detailing, and the architectural sort of approach to the system then culminates in some of these projects which we've built. So this is a bit of a case study which we documented and got a photographer to look into. So we've got a few images to run through from this one. So this is a display suite that we actually did for Milieu, and it's down in Elstonwick if you're around in Melbourne and ever want the chance to have a look. So it's up for another year or so for a multi-building apartment complex that they're doing. And so the display suite was our full platform. So we basically did from the stumps up, and you can see here some photos of the assembly process for our roof cassettes. So these are all glulam beams, 240 by 60, and some of the machining, so the mortise and tenon detailing and pre-drilling that goes on there. And then here's examples of the assembly process for our facade frames. So those are machined in factory, painted and finished, the gaskets installed and some of the hardware installed. And you'll see down there our sub-sill system that we've designed, which Josh will sort of step you through in a later project example. So all those components are panelized and assembled in factory and then delivered to site. And then the project builder is responsible for creating the foundation structure to support it. And that can vary depending on the project and the engineering. So this one, because it's a temporary building, had these kind of unique stumps that are fixed into the asphalt of the project. So the floor cassettes are then dropped onto these bearer structures with some timber blocking underneath. And the simple connection for this is basically it's screwed down through the joist and the cassettes and into that blocking, connecting it to the structure below. You then have your wall cassettes or wall panels that come in, and you'll note here that it is basically, or it is just a timber frame, and we've been quite conscious about designing our system to be standard timber framing, learning from those lessons around SIPs that we wanted any builder to look at our system and be like, okay, I understand that, I can work with that. And also if things need to change on site or something's been missed, they also know how to fix it, how to work with it as well. Although, that's a rare occurrence that does happen. But it also means, in the future, if you want to renovate, if you want to change it, then there's a really easy path to do that as well. So because we set up our business to be something that we want to be able to supply around the whole country, and we want to work with local builders and local consultant teams, we want it to be a system that anyone could use. And 99.9% of the trades, like of builders in Australia, work with timber framing. So that was a really key lesson for us and a key focus from our previous experience. So at this framing stage, you can see how then the facade frames are also dropped in and propped during that wall assembly step. And then the roof cassettes come in pre-assembled as well. So this one is an example of sort of up to the limits of what our roof cassettes can be. So this is about 6.5 meters across here, and they can go in incredibly quickly. So these ones were going from lift to lift, so panel to panel, in about 6.5 minutes to install. So we typically advise it to allow about a week of each stage. So the floor for a week, walls and facade for a week, roof for a week, and that allows an install day of typically, well, only a day or two, but then time to fix off, make sure it's really accurate and correct, and a bit of contingency around that. But it really means you're getting to lock up for our buildings in sort of 4 to 5 weeks rather than the multiple months that it normally takes. And that's the sort of efficiencies or time-saving gains that we're able to offer. You'll notice on a lot of our projects we do site glazing, like here, and we have tested factory versus site glazing as well. And this is one of those, I think, assumptions that you make before you do a business like ours, is that it obviously makes sense to factory glaze and transport them as assembled unit, list them into place. But we actually found that the logistics of that is just so much more challenging. You can transport much less. You have to be so much more careful around it, that it's actually faster to just site glaze, especially for these kind of accessible buildings. So we can glaze that. This is a 300 square meter floor area building with one sort of long facade and wrap around the edges, all glazed. That got glazed in about 4 hours, and then about a day to fix off all the caps. So this image here sort of shows the end of our scope for this project in terms of that structural frame and envelope effectively at lockup. So above this, we've also done the eave cassettes and the roof rafter system to create that fall. And then the builders come in and do the linings and finishings and all the internal trades and those kind of things. So this is then some of those imagery of the project once it's completed, once all those additionals are added on. So this is a project that's designed by Woods Bagot, and they were wanting to kind of connect back to some of the mid-century modern aesthetics around dark stained verticals. So you see those mullions have that dark ebony stain, and then a light whitewash in the ceiling rafters, and then the integration of different furnishings and different kitchens and different internal finishes as well. So you can see the way that we can block out and provide different noggings to allow for bulkheads and other things with the sort of structural line running behind that in this project here. You'll notice in a few of our projects and detailing that we have a few options around how the floor meets the head and the sill. Josh will step you through some of those examples there, but this is an example of where the floor basically is and it runs into the lower side of the facade, but we typically advise it to be recessed down, or you're battening up the floor so you get that flush finish, similar to what you've got across here between the ceiling cassettes and that head as well.
Cool. Well, this is where I'll jump in. Thanks, Jas. You slowed it down there a bit at the end, which made me feel better. You were going all cylinders, and I was a little worried. I don't think I can talk that fast. I think I'm glad you mentioned it quite clearly in there. Milieu was really notable one for us as well, because it wasn't an Archer designed project. A lot of Candour's early days jobs, because it was a spin-off from Archer, were Archer projects. And Jas will talk about that just briefly later. Like, more and more that balance is shifting away. Part of the reason, I don't know if you mentioned this, Jas, I don't think you mentioned this, was we spun off Candour rather than keeping it internal, so that it could address a larger market. It was bigger than just one practice. But anyway, this is I'll run through. I've got 2 jobs. I will be quite quick because we are a bit behind. We're quite eager to hear what you guys want to ask us and talk to. So this is Yandoit. This is a rural Victoria project, a few hours out of the city. Are you going to click through the slides, Jas, or do I? Yeah, cool. Yeah, rural, designed by Archer about 2 or so years ago. And this one is a hybrid. So it's, as you can start to make out there, it's got a slab on ground. This was previously like cheap grazing. The clients are really starting to reintegrate it to the landscape. So here, slab on ground. This was not the original intent, but it came about to help with the thermal mass. Being where it's located, it gets very hot, but it can also get very cold. And as part of the ESD solution, just to really max it out, we went for yeah, slab on ground to get that thermal regulation.
And this is a great example of how we can work in with conventional building systems as well. Like you're not locked into doing it one certain way or using the whole platform, but you can combine it. And this project, we did the facade, or the facade system, walls and ceiling cassettes, and the builder obviously did the slab and then the roof structure and eaves as well.
That's it. And a minor thing, but what you just mentioned before with milieu was part of the benefit of using just a traditional-ish systems is you can swap it out as well. So this project, as just mentioned, it had the walls. A few of them went up first just to help with the windows. We sent out in advance the subseal, and it's let's say proprietary, but it's just a custom subseal that can get fixed off, like set out, fixed off, packed and leveled, so that by the time you arrive with the frames, you're not hanging around trying to set it all out with things hanging off a crane. And Jas, I think you were saying, so this building's approximately, I'm going to say 10 by 11, so it's not quite a square. And the entire envelope, if you go to the next slide, Jas, the entire envelope is the curtain wall system. And did you say, Jas, that went up in 4 hours?
Yeah, so because of that, subseal track is basically installed before you arrive, and then we provide these corresponding cleats on the underside of the facade. It allows you just to drop them in, and it naturally nests into its precise location that you can then shuffle sort of left and right to get it to work. But it means that you can get those frames up and propped incredibly quickly. And then we have all these clips that we use to connect them up, and you'll notice that lintel beam that then rings around the outside is then used to sort of structurally tie it all together and link them together. So obviously this one being a square plan, it's a full ring beam, but typically we would have that runs across the top of the facades and integrated into potentially across other elements as well.
That's it. So then this was also roof panels. And as you can see, this was them staging it. We'd sent out the panels. They'd preemptively spaced them out so they could just lift them up one at a time. And this, Jas, you were saying, I wasn't there. I'm based in Hobart. Jas was there, and it took 8 hours to get the roof in. And I think you mentioned there was a few misunderstandings or something that we probably could have got it down to more like 6 hours. And
yeah, basically the builders installed that lintel slightly in the wrong position, which made it just that much more tight to get them in. But the other thing that sort of was a bit slower than normal was Arch's design preference to have a change in direction of the rafters. So you'll notice that it's sort of going in a cruciform, which is sort of an architectural design choice, but it made it a bit more complex in terms of install rather than just sort of running them consistently across in one direction. But I think the key thing there is it took 8 hours with that added complexity, and we could have even reduced that further. And that connects back to, say, the milieu project, as I mentioned, like 300 square meters that was done in a day of installing that roof.
Yeah, so that was actually pretty challenging and interesting. How do we have a structural roof panel that is changing direction, that needs to be split, and that was part of the fun of solving this project. In this instance, this was a 240 glue lam with a plywood top. That's all nailed down to the bracing standard, so this forms a big diaphragm. And then we had PIR foam on top. And from Arch's perspective, we were looking for a very thin roof build-up, but we still wanted that super high performance. A minor thing here, for example, as Jas said before, we build a lot of the construction logic into the panels. So here we have like a wailing plate. You can just see that, which just helps you drop it down onto the facade. So you're not trying to balance it, hold it, level it. It all drops in. It can sit there as you fix it off.
Yeah, and I think one of the things to note here is we're quite focused on keeping our detailing and systems simple and logical. So the way this works is that wailing plate is sitting on top of the facade. The actual underside of the roof cassette is then flush with that underside of the facade, and you're basically connecting, so up through the facade into the lintel, and then across through the lintel into that wailing plate to fix it all together. And I basically like that sort of screw connection.
So this project, we this was a little earlier than Milieu. This is how Archer typically does their roof framing, and Candour didn't do that. But this is sort of the finished product as an overall. Maybe just to flick through a few more, Jas, because there are a few to come. Uh, Here you can see 100% facade, but we did have some infill panels, and that was a response to the engineer. Unfortunately, we needed to brace the building. And so each facade has one, if not maybe two. But Jas mentioned this earlier, they were also just panels that we pre-sheeted, double-sided with OSB. So they were rock solid. And that one small bit of bracing was enough for that entire elevation. And that was just pushed into the panel. And
you often need a place to hang a picture or something like that. So that's what those can become.
You'll see a common complaint that there's too much glass and not enough place for artwork. But
yeah. You'll see in some of these images the kind of bolt fixing details that we can either display and detail so that they're a part of the architecture, or you can conceal them through plugs and other things as well, or even just concealed fixings completely.
Just quickly before you skip, you've skipped. What we can see there now is that infill panel that was then glazed over with a spandrel panel. And to Jas's point before, that continuity and consistency of the detailing meant that glass just went straight up. And glass itself is surprisingly cheap. And so that was cheaper, quicker, everything, and better than like a clad wall. And the processes required to do that.
Where we're going to be. Oh, yeah. And then this is the outcome, the finished product. And so you can see there the kind of examples of how that spandrel panel works and how you get that consistent sort of architectural expression of that glazed wall, but you can still have internal panels. You can see hints of some of the operable doors and windows that integrate into the facade as well. So you can see there that Archer chose to contrast the color, and that dark aligns with the outside finishes. But it actually works really nicely because it's obviously set back in with the clear coat timber internally as well. So basically the way our system works is you can either have fixed glazing, or there's just an opening left between the mullions where you might have your big sliders or your operable doors and windows, or a fixed wall as well. And that cladding externally, or the lining, doesn't necessarily have to be a piece of glass. It could be a sheet product, timber boards, or many others. So you can start to see here some of the different detailing options as well in terms of how the floor meets the sill. So that's that flush condition with a little bit of a quirk there. And then similar to Milieu, that flush condition at the head where the head aligns with the underside of the rafters. And so we find that because you get that extra volume effectively, or head height through those exposed rafters, you can create a building that feels really large or really voluminous. And it's, it might be only 2.5 or 2.7 meters to the underside of that ceiling. This house in particular was only 2.5 to the underside here, but it feels much larger in that space. And then Milieu, in contrast, 2.7 plus the 240 of the rafters there as well.
Do you want to maybe whiz through this, Jas, and
Yeah, sure. Originally
we're a bit over time, by the way, so everyone knows we'll go until like 10 past. So it'll be great to start. We have a few great questions coming in. So
we might keep moving through it then. But just in terms of cost, because I know that's often a first question for everyone. We have found that for about a 3-bedroom scale home, so about 200 square meters, that to do the full platform, which is shown in this diagram, including the floor panels, roof, facade, walls, everything with the glazing, with the operable doors and windows, and these are BINC high performance doors and windows, we're about 2,500 a square meter of supply. And that is usually about a third of the total project costs. This is on an accessible, reasonably located site. Like obviously if it's more complex or steep or that kind of thing, it might increase the prices there. But that works out to be a starting point of around 7,000 sort of a square meter, which we feel is really good value for the kind of level of product we're getting. And for that previous project in Yandoit, we did do some testing of pricing to what it would be conventionally. We're finding we were sort of 30, 40, 50% cheaper to produce that same quality of building compared to conventional. So we feel like we're really good value for the quality we're providing. We're not a low cost product, clearly, but as I mentioned at the start, we do, as we sort of scale and connect with other suppliers, we do want to be able to provide that sort of other low, like sort of mid-range options as well. And also into other segments of the market. So it might be commercial or into multi-res and those kind of things. And often with those ones, because you're just scaling up and there's repetition, you can also have more efficiencies, which allows lowering the cost.
Okay, speed round. Jas is already halfway through the slides. So this is Taroona. It was a recent recipient of the Australian Timber Design Awards. And what we're seeing here is a difference here is it's multi-level. The structural system is taking that. It's a steep and difficult site, and that's what led to us designing it as a panelized solution. To what Jas said before, it was so steep and access was so hard, there was no staging area. So it was sent as parts and it was assembled and then installed on site. And the logic, the builder could put it together, like for the first time using the system. Another point is to get out of the ground, there is a bit of steel to build those platforms because of the site, but from then on, it's 99% timber. And just that minimal use of steel from an embodied energy is quite important to some of the clients, like for Archer and Candour. And what you can just make out here, but it was an integrated structure as well. So similar to Yandoit, the facade, the walls, and the roof panels were all working together to create a diaphragm that helped brace it. And there's a green roof; it's taking up that load as well. A few of the details, so Jas talked about in the last one with Yandoit, where we set out everything flush. With this one, you can see we've actually run the facade past. So the sill is set down and the head is set up, and that gives you that really expansive outlook. And you can see here, it feels like you're in the camp, like you literally are about 3 meters away from some of those trees.
Yeah, it's a pretty intense experience being in this space, looking down to the Derwent River and hovering above the tree line.
And a common comment from clients or people is, I look so open and exposed, but you are surrounded by bush and you actually feel enclosed. It's just not the walls that are doing it. It's the landscape a few meters away. Finally, infill panel there behind that.
Sorry, keep skipping to the wrong slide.
Yeah, no, sorry. I just did really want to point that out because that is a beautiful way to finish what was a structural requirement. So that was how we a lesson we learned from Yandoit is how do we make these features.
I might just run through this one pretty quickly if I can jump in, Josh. Where
please
just included this one at the end. This is a project we're doing for a university building Tasmania, just to highlight that we also do custom fabrication jobs that are not designed by, or not our system. So this is designed by Woods Bagot again, this whole building and this facade system. And then we've just come in as the manufacturers or the machiners of the timber itself. So we've provided the CNC machining and finishing for all of those, the system and all the plugs and things, and then other contractors are installing the glazing. So if you ever have any projects that need or would benefit from the kind of intricate detailing and design consideration that we can offer, feel free to reach out for that as well. And this is just to illustrate some of the projects that are on our drawing board. So from a range of different architects, including looking just at these ones, JCB, Edition Office, Wardle, and Claire Cousins. So there's quite a few local ones and a range down in Tassie as well, and quite a few more that are not represented here. But if you are keen to work with us, please feel free to reach out. Whilst we haven't released our tools as yet for everyone else to use, the process now is for basically myself to work with you to quickly model it, quickly price it for you, allow you to get that experience of that price certainty and design input from early on. So that's us. Thanks for the opportunity and look forward to your questions.
Yeah, fantastic presentation, and one of the most cohesive philosophies that I've I've seen, it's clear that you guys, along with your colleagues, have developed quite a tight philosophy and gone through this journey together. In that sense, is this like, when you think of your story and your journey and how you got here and where you're going to go, is this a step change that came from one moment where you thought enough's enough and we have to do this differently, or is this part of a longer trend?
I mean, it's definitely part of a longer trend. I think we've all individually been really a combination of interested and frustrated by the architectural and construction process, and interested in how we could better it. And then our professional experience of being frustrated by how it just seems to be getting harder if you're just following the conventional processes, and thinking that, not a common thought. I know, I mean, not an uncommon thought. Sorry, I know a lot of people think this is like, there's got to be a better way, and there's got to be ways to harness technology to improve this as well. I think what we've tried to do is really look at what other people have done and often what hasn't worked and learn those lessons. Obviously we could be wrong, but we're trying to, produce a process, not a product, so to speak, and something that we can offer to the whole industry. It's not a sort of closed or locked system. There's lots of flexibility in it. And one of the biggest things that we felt as designers trying to use prefab is that you're often, you're locked in, like it's not customizable easily. So we really wanted to build something that gives that complete, like a lot of flexibility from the start, and combined with price certainty and the other benefits that prefab offers. So yeah, it's been a long journey. Like, it's sort of decades in the making in many ways to get to here.
Your plant-on system, is it Raynars?
It's actually from Stabilux. So it's a similar,
okay.
Yeah. So there's a few of them around that do it, but interestingly, they're all from that same area within sort of Central Europe.
It's pretty common over in Germany, and it's yeah, there's a lot of systems that are very similar, I guess.
Why have you been able to do this when other BIM packages have not?
Can I have a Jas?
Well, my quick response to that would be that often you see startups in this space who are not connected to the manufacturers, or not the manufacturers themselves. Like, they have a similar idea, but then a lot of existing manufacturers, they're very risk averse for obvious reasons. Like, they've invested a lot of money in their processes and equipment, and for them to change that process is very costly and very risky. And we found this out, like, before we actually officially launched Candour, we spent years going around trying to do that. Like, we're saying, well, we can build the software, we can build the process, and then you guys as manufacturers, you come on board with that. And whilst we got interest, it came to the point where we had all these projects banked up, and we couldn't actually get that commitment to actually deploy our products and our process. So we kind of had that moment of like, well, we've either got to get the commitment or start our own factory. And then we started our own factory in a small space out in Altona.
Which
so I think it
takes the form of that singular, very diverse machine.
Yeah, well, this is before we got that, so we were still getting other people to like do the CNCing work, but it was basically saying to have that digital process, that BIM process that's connected to manufacturing and having that certainty, we need to be that manufacturer. And the way that we see it currently is that we're almost the proof of concept. Like, Candour as a manufacturing prefab platform is proving that this is possible. And then, as mentioned, we want to have other suppliers on there. Like, they can see that it works for us. We've resolved it for, we're probably the most complex case study of it. If you look at CLT or other panelized products, they're much simpler. There's much fewer variables than what we've solved for ourselves. And they can see the value of it. They can see the kind of the pipeline that it could generate for them, and the certainty that it gives their customers. Because often that's the biggest thing. People just don't know how much it's going to cost and how it's going to integrate.
And to add on to that, like a slightly different tact as well, is that it didn't just happen overnight. It was a very iterative approach. And as Jas mentioned, so the 5 Yards house was the first SIPS panel. Someone's actually asked the question, there was actually a bottom plate, bolt the bottom plate down. and then you slide the SIPS panel on. That is the best way to do it. Couldn't confirm if 5 Yards did that because that was one of the first ones, but we sort of got there very iteratively. So I think we've lived it and we've built a lot of our own houses, like in the office, we've either renovated or built. So I guess the reason I think we have arrived at this is we've tried it ourselves, and we were the guinea pigs for a lot of that. And we had clients that were willing to give that a go because they were coming to us because we were looking at new and innovative ways to achieve a great architectural outcome. And another question in there as well is around the performance. Like, we really value natural light, and especially down here in Hobart, that opening of the facade actually helps heat the house in winter. Got to be careful at night. And so we've really balanced this high performance, thermally broken. You know, it's a pretty standard thing in Germany, but for Australia, it's the bee's knees. And we balance that with really well insulated walls, you know, well built and wrapped envelopes. And yeah, we just sort of iteratively got there. And sorry, actually, where I was going with that was from our perspective, we were trying to get other suppliers to produce this, which was a premium architectural project outcome, such as exposed glulam facades and roof panels. But we were small fry in a lot of the world. Like, people were cutting it out, but we were a lower priority. There were more profitable outcomes, like cutting trusses. Like, Hundiggers are great at just cutting timber to length, and you know, the speed cut is great at that. But we were taking it from a slightly different tact, and yeah, we got to this point where other suppliers, early days, some of the people we were trying to partner with just went under, and so in the end we were like, well, we've kind of got to do it. And that was that sort of leap of faith moment.
To what extent would you feel that you are geographically committed? And perhaps that's not quite the right word, but there's some degree to which this solution is bespoke to the supply chain that's near you, and that will take the form of both your own expertise and also the ability to transport, but also to a lesser extent regulatory compliance across the country. So how do you think about that problem?
Well, we've actually, that's been a really top consideration from the start, because we wanted to create a system that you could supply the whole country with. And the way that we plan to do that is, say, we're actually doing a project over in WA this year, and we're looking to connect with local prefab companies over there that can make some of the more standardized elements, like the wall panels and the floor panels. And there's, to be honest, there's other businesses that are already scaled up that can do that more efficiently, more cost effectively than we can. So why should we try and do it? Like, we want to create a platform that enables the industry to flourish and makes it sort of easier for everyone to draw on those benefits. Like, we want to send the wall frames to wall frame producers and allow us to do the stuff that's unique to us as well. So that's how we want to build that network and expand geographically through that process. But I guess another benefit of it being panelized is the logistics costs. Whilst yes, delivery can be expensive, it's often much, much less than the modular, because you're able to compress it and be much more efficient around the transport of it. But similarly, say if we're looking to, where we've got a couple of projects in New Zealand we're looking at, and even including the transport costs, it seems like we're more cost effective than to do some of the things locally. But we're also we're talking to some businesses over there to say, well, can you guys, if we did the machining and the finishing of the parts, we send you that in a really efficient packing, they then assemble it over there, and then they do the walls and the floors and the simple things that they can source and do themselves as well. So we can almost franchise or subcontract that out to do it. And then the digital platform and the design tools then become a common way of feeding that work out to people.
That's brilliant. Yeah, like I'm watching you guys very closely. I'm sure many other people are too. I want to ask the question: why not steel? What drove that? Is it a malleability question? Is it simply what you guys can most easily change and bit right, as opposed to being a metal fabrication shop where you're welding and cutting steel?
Yeah.
What's
I
the
think
rationale?
at Archer, we've always had an interest in things that we could get involved with. And I think there's definitely a sustainability element to it. Steel is efficient, don't get me wrong, but it is also dirty. And there's one thing that we didn't emphasize too much was a lot of these projects, the structure is the finish. We've just rolled two into one. And steel, that's kind of beautiful. It can be beautiful, but timber is beautiful. It creates warmth. You can really affect the emotion of a space. So I think we were maybe more drawn to that, with the idea of, like, at Archer, we're fan of materials that will age with grace and dignity. And steel, it's in, and it is what it is. It's quite static.
I'd add to those comments, Josh. Like, I think a big driver is around the health of buildings and the psychological health of buildings and things that timber can offer. But the other, even connecting back to one of those early lessons, we often found combining multiple systems in the project and the different tolerances of those, that causes challenges around building performance and airtight envelopes and those kind of things. If we control through one system, timber, steel, whatever, but we've chosen timber, then we can control those tolerances and control the execution much more tightly.
Steel would be great because it's so much probably easier than timber, but timber's fun. Like, you know what I mean? Like, we could get it cut out, CNC machine. We did some early fabrication, like as Archer's early days with steelwork furniture, and it's very precise, but it's also not got much going for it.
That's a wonderful answer, man. Thank you. Thank you very much for sharing your thoughts on that. And thank you for such a fantastic presentation. We're out of time. We do have to get to an hour. And thanks everyone for sticking by the overtime, and apologies again for the kerfuffle at the beginning. So please join me in thanking Josh and Jas for being here today. And I'll just do the wrap up before we go. Okay. So yeah, thank you for being here today. And thank you everyone for joining us in this installation of the WoodSolutions webinar series. The next installation will be on Tuesday, the 3rd of June at 11 a.m. on Glen Post and Beam Passive House. So be sure to come along to that. That'll be a very interesting discussion with Niall and Robert Nestick. Of course, the 26th Australian Timber Design Awards is on this year. So if you know any projects that you think would do well in the runnings, please let their project teams know that we're now accepting entries for this year's competition. Thank you very much, and we'll see you all in the next installment.